So if I blow myself up, you guys will get to see it. Anyway, I have a couple high walls here. This one here is blowing ice cold. That's hooked up to my Frederick outdoor unit that I did a lot of hacking to make these two work together. It's kind of be a shame when I take it apart just because it cools very well. So basically, this is rigged to where there's nothing hooked up to the swing. I just move it manually, and the fan is actually interfaced to the Frederick unit, where I made a circuit board microprocessor sending the right voltage to this motor, and then the tachometer, I had to go through a microprocessor and change the frequency to feed to the VRP Frederick to what it expected for frequency, which is a lot slower than rotations of these little small diameter motors. So I have another one here. This is the one I'm going to use. I'm going to hook it up before I take this one apart. I'm going to put it right here, I think, and I'm going to tie it to my homemade heat pump that's on my water heater here. Except for that's all 120 volts. That's 120 volts. So I already showed you guys in a video before. I'm going to turn this on. It's going to go on. I actually right now just have the 120 volts from this outlet just plugged in. 120 volts AC, and so the resulting DC at the fan motor through the rectifier is only 167 volts. 170 basically what it runs at. Oh, looks like it's might be going back on memory here. There goes, the fan's going to start. I actually ran this for like a day and a half off the 120 volts and never got a fault, nothing. Now that just turned the fan only and not trying to set for cool or something, which it would eventually probably stop on a fault because it won't communicate with no outdoor unit talking to it between L2 and S. So I just have 115 volts, 120 basically, put in these two terminals right here. The fan's running. I should have put a piece of paper on there again like I did before. So let's do that. Set the phone down for a second. This is a more accurate gauge than using a tool, right? To read CFM or feet per minute, actually, probably. So there it goes. You can kind of see. We'll see if it blows any harder when I hook it up to the actual full 330 volt DC that you would get for a 230 volt system. So what I'm going to do is, you can see 165 volts with the motor kind of pulled up on high. I'm going to turn this off. Capacitor is going to discharge in there, and I think I'm going to take this probe off and I'm going to put it right here on this diode. So this stays common to the negative. It's DC. I'm going from AC to DC of what I'm feeding in here now. So, and then this leg goes through the positive side of the capacitor. You got the a diode this way and a diode that way, and what it does is when you have the positive edge of your sine wave, it charges the capacitor, and it's going to get 170 volts DC. And then the other way, it's going to basically series this capacitor with the capacitor inside, and and it's going to basically dump and charge the capacitor inside to double the voltage. It's going to be about 330 volts. So turn it on, watch the sparks. I've already had it working, but that's a good sound, and look at that, 330 volts. See if this thing's going to kick back on, or I'll have to use the remote. Most of the time I'll have to use the remote, so I probably had it off too long. Off, back on. Should go to fan high. There goes the louver, the swing arm, there it goes. Kicking on. See how much voltage sag I get. I have these little tiny diodes on there. I mean, they're small. But you know what? These motors pull like 30 watts or something ridiculous. Maybe it's a little more than that, but it's not much. Yeah, I don't know, you be the judge. I actually think the fan motor achieved its full speed on 120 volts, so I don't know if I even bother with the voltage doubler, but sagging down to 327 with the fan running. Simple, 2 diodes and a capacitor. I could just wire that up, heat shrink it, and just stick it in here. It doesn't even matter, or actually, it doesn't matter what polarity it is, because it's steering itself through the full wave rectifier inside, and it's just using 2 of the 4 diodes all the time, since it's not alternating current, it's direct current going in. And that's, so just kind of but I think it's blowing about the same as it was on the 120. Unless it's a pinch more. It is spin. Paper's now kind of doing that. Should have added 2 pieces of tape. Yeah, no smoke. Turn it back off there. Yeah, I don't know, just an idea. And I would probably try a larger version of the capacitors and diodes to voltage double to the Frederick without using a transformer. But that would take a lot more current. This works for small current things. It can work for bigger ones, I guess, as long as you use possibly. It's only half-wave rectification though, so I don't know. It probably might sag a little bit. I wouldn't, but who knows? But I think that I tried hooking DC straight up to that Frederick before when I first had it, when it was all together, trying to run right off of solar, and all the lights lit up, the fan turned on and stuff, but it gave me like a fault, and I think we were thinking it was missing a 0 crossing, which obviously when you just stick DC into here, you don't get any 0 crossing either. Trying to think. I mean, you might get on one wave. You might be. I don't know. It's like I said, it's putting capacitors in series to charge up the second one. It might actually go plus minus. It might not just ever have a negative half of the sine wave. It'll be just all one half or whatever. Who knows? I would have to let this run for a while and see if it stops on a fault while I'm doing everything else. So anyway, the other thing I was doing today was, I know it's pretty shitty, but I was just slapping up some drywall real quick. I don't have any patience wait for my drywall friend. I mean, it's not horrible. I think it'll look fine. What do you guys think? Don't answer. So got a couple people in here live now. Got Zaw Air and Heating and Roy. Took a Goodman cover and used it. Installed a Trane American Standard, and my installer lost the cover and the bottom piece for the control door. So it took a Goodman cover. Dude, that's what we call blasphemy in the HDC. Put a Goodman cover on your Trane. Man, you better repent. Anyway, you guys might have to rewind the video. I was just doing it live. Rewind it when I get done. Just doing it live so I wouldn't have to edit clips and upload it. But basically, it was a little experiment just to use a voltage doubler to take 115 volts, which only makes 170 volts DC on the DC bus. When this is a 230 volt unit, and the DC bus is supposed to be 300 or 330, depending if you use 208 or 230. So using a simple 2 diodes and a capacitor and just sticking it in there, sticking DC in there, I'm able to do a voltage doubler circuit, which is this, right? And then this capacitor here is actually the one that's inside. I didn't need to add that one. So C2 is the one that's already inside on the circuit board. I added C1 and the 2 diodes. And this is your line voltage coming in, from utility power. And it charged it up to full DC voltage, 335, when you only get about 170 if you just stick half the AC voltage in here. So I think we're good. Get a piece of tape on here. Fan really gets going. There we go. About how it's blowing. And like I showed the guys before, it won't get any sparks when I move this stuff around to discharging caps or anything. There we go. If I just run straight 120 into this thing, see, it only gives me half the voltage.
I close that thing
Anyway, yeah.
When I close the door, it's off. Like,
I'm live streaming. So. Turn it on here. I think it blows almost as hard, even though it's under voltage. That it's electronic motor, and it tries to just probably do pulse width modulation to the permanent magnet motor just to get it up to the same CFM. It does seem to maybe have a little less torque getting going. Let's see what it looks like. I know it takes a few seconds to get full speed. I know it might be blowing a little less hard. Now I left it, like I said earlier in the video when I started the live stream, I left it on 120 feet in this, see if it would do any faults. Just fan, without cooler heat, so it wouldn't freak out from not communicating. And actually ramping up pretty decent. Going pretty decent on 120. I don't know. It makes me wonder if it's even worth putting in the voltage doubler, because it actually blows, and I left it connected for like a day and a half and it ran. The only thing I use this thing for is just to turn it on, and of course if the power goes out, I don't know if it'll have memory, so I might actually, once I get, I mean, I should almost just gut this and put just bypass it all and just put power right to the frickin' fan motor, DC power, and a fixed voltage going in just for the speed. But then I could probably put a potentiometer or whatever on there. I don't care about a feedback signal because there's no board. There wouldn't be any board in that case that would freak out from a missing tachometer. I don't have to make up my mind real quick. The other thing I need to do while this is open is take the two thermistors on the coil off of the circuit board in here, and then hook them up to a cable to run outside to my controller. Unless I mount the controller inside, which I might do. Might put it, I don't know. I have another control box, I think. Well, plus I have this white one over here. I took my other guts out of something else. But I think oh man, just lost it. I think I have another one of these boxes. I could build my little microprocessor controller mounted on the wall right next to this thing so I could get to it from in here and do my tweaking to adjust. I was gonna, if I put the expansion valve in here. I don't know, man. I was probably gonna put the expansion valve outside, right at the outdoor unit, like they normally are. And then I just need to run the two thermistors, the coil in and out. I just need to run it through a cable to the outside to my microprocessor to read, so I can make it adjust the expansion valve. I don't know, it's running pretty good. Flip it off one more time. Back to the higher voltage. See if it. Check the console made for that. A Janitrain. That's still an abomination. Yeah, it is a weird project. I'm psycho enough to do this stuff. But I grew up in Redneckville where we made our own tools. I used to work for like a redneck auto shop when I was younger. My first job was actually in kind of like working on RVs and auto mechanic stuff, learning and everything. 17 years old, full-time job doing that. And I was already working on cars as a teenager, but electrical and stuff. I think it might be blowing just a pinch harder. And I think the torque to start is a little better, but maybe I'll put a voltage doubler on it. Probably put that outside in the outdoor unit, just run these two lines in. It'll just be DC going in. But yeah, that's the idea. But it'll be cool. And the reason I'm doing this is because I could right now, if I just want AC in here, the cheapest way to have just purpose AC just to cool this little room and put the door on is if I go buy one of those Mirage $450, 1 ton or maybe a little smaller mini splits that they sell. People are selling them locally. You could go on like Facebook Market or whatever it's called, or Craigslist and stuff, and people are selling mini splits, cheap ones. What is it, McGree or something like that? And there's Mirage is one of the brands. $450, you get a whole unit. I mean, that's a throwaway price, man. The only reason that I'm going through this, even though I want AC in there real quick, is the whole idea is to merge my cooling in here with my heat pump I made for my water heater. It's outside. Put it all in a new cabinet out there. Split the coil because the coil is big enough for to use half of it for a condenser and half of it for evaporator, and I'm just going to series the discharge going through the heat exchanger with the pump water, and then through the coil, and then basically, if the water heater is getting too hot, I'm going to have it stop the water pump and turn on the outdoor fan. And then having that coil after the heat exchanger will probably bring the subcooling down a little better than right now. You know, when the water's at 130, it's 130 degree water cooling the refrigerant. Which, hot day with the coil a little dirty, that's what you're cooling the condenser with anyway. So it's not that bad, but it'll get a little better performance. You know, or if I just probably let it run through the other coil even without the fan running, it'll probably drop it down and subcool it properly. I might actually put a little receiver on it, but right now it's a capillary tube system, and I have a little receiver saved for a long time. New one when you buy those little condenser things, sometimes the one they'll have in stock for a low temp unit will have a receiver, but the unit I'm working on has a capillary tube, so I'll just take off the receiver. So I've saved one or two of those over the years. Never had refrigerant in it. Hopefully it's still good on my junk. So anyway, and then I think I told you guys in another video. So this would be like the main evaporator on that system. But in the winter, I don't want it to like make this room colder when it needs to heat water. And in the winter, the water heater runs more. And then I'm going to, you know, try to heat the room just off the computer that's going to be running in there. And the fact that a fridge is in there and stuff, and hopefully I never freeze. So I'm going to probably come out from my liquid line to 2 electronic expansion valves. One's going to feed this and one's going to feed the other one. And they do pump down. They'll close all the way. So I'll close the outdoor one all the way and then meter this. And then when it's... I think when in the winter, then maybe I'll just open the other one and then a meter to that one, which means I probably need 2 circuits then, huh? And to run the 2 expansion valves. But if I get the one working for in here, I have all the way till the winter time, you know, to install the other one in the outdoor unit, and I could just manually close the valve. Now that I have a circuit, as you guys saw in yesterday's video, circuit made that's running these electronic. Oh wait. So I can run that. That's opening the valve because we're looking at it upside down, and it's winding in. When you go this way, it winds the needle down, and it closes. I have a little. That's just my own circuit, just for seeing what I'm doing. There's my steps. Close the valve. Actually, I think I'm going to make a little handheld thing off a 12-volt battery and everything and put it in a box and have the plug for these common expansion valves. And then I'm going to be able to walk up and just, when I need to go out there and open one manually or close it, I'm going to be able to just plug it in. That's going to be awesome. But anyway, that's the idea. It's hot in this room right now. I don't have any fan blowing in here. Like, it's only cold like right in front of this thing. It's nice right here. So, I don't know. It's blowing. I don't know if I'm going to hook voltage up or I'm indecisive. But anyway, I need to get to mess with some paint in here now that I think that drywall's about to that point. So I can get this done and put a shelf back up there once I get the paint on. It's holding me up from picking things up off the floor and whatnot. And I need to stuff some stuff over there. So anyway, with that, don't forget to like and subscribe. You're going to see a lot more Frankenstein stuff coming up, especially if I can be comfortable for a while and work on my electronics. With that, I'll catch you guys later, man. And check the comments one more time. See what you guys are saying. Yeah, we have Pep Boys here. There's only a few of them, so I hardly ever go there. It heats a hot tub. Yeah, anything like that, Jamie. You take a water source heat pump. You could take the water source heat pump as a whole in your case and just heat the hot tub. The reason I knew that would probably work, because I used water source heat pump in its raw form to heat my water the first time, is that if you slow down the gallons per minute a little bit, the head pressure would go up a little bit, but it would still run a little hard, but it would run and you get that 130 degree water. So hot tubs actually don't even need as hot as a hot bath. What do you run in a hot tub? 105, 110, maybe 115. So you just take a water source heat pump, put a pump on there, and heat your hot tub and cool at the same time. So, yep. Or you could just add a heat exchanger to your AC unit on your house. Put it in series. Anyway, with that, I got to get going. So don't forget to like and subscribe, just like I said, and we'll catch you guys later.